Thank you so much. So welcome to this closing session. Now I'm Teruo Fujii. It is indeed my great pleasure to chair this session. So this is for the session to see the future. And the question is, where will you take us? But then this question is not only for the panelists, but also for all of you in the audience, the scientists, the researchers, especially for young generation. So by the way, let me start by asking the panelists to give us brief speeches, say 3 minutes, hopefully, please. And talking about your bold thoughts on how far we can go at the frontier of life sciences in the next couple of decades. And also those may, of course, include some of the reflections from today's discussion. So let me ask Ada, Professor Yonath, to start. Yeah.
Good afternoon, and I wish that the last session will be as good as the rest of the conference. And I would like to start with declaring that science, and science that is interesting for the Nobel Prize winners and for those that want to be Nobel Prize winners and those that want to do good science in general, science is meant to improve life, to make life as good as possible for human beings. And I don't want to bring too many examples, because I know that everybody here has his own or her own idea what is good life. But in principle, good life is actually better than now. Now it's good, but it will be very good, or should be very good and very thought about being good for human being. Good in all aspects of life, in education, in health, in possibilities, and so on. So my own part in it is to wish the best for human beings, the best also for other animals. Thank you.
Thank you. Thank you so much. So, okay, please, Martin, please.
So I'm not very good at predicting. I find this a difficult thing. It's not the way I do my science either. The way I do my science is I do an experiment, and then I let the experiment sort of surprise me into what I'm doing. I'm a geneticist, and genetics is one of the, at least to me, is one of the more interesting approaches to science, because we look at a phenomenon, we get a mutant, we clone the gene, and we suddenly discover we have no idea what that gene product is doing, or that we've never studied that, and we're off on a completely new area that we learn about. So to me, the important thing about the future is to be able to do the experiments, to be able to look at all these things and proceed from what they begin to tell us. I think a very important part of all this is education. Being able to give people the opportunity to make those discoveries. And I think that's really one of the most essential things. So I'm not going to say what I think is going to come in the future. I just hope that we can give that opportunity to as many people as possible to make those discoveries.
Okay, thank you so much. So good for human being from Ada and from Martin to be able to become experiment, to do experiment, and also the importance of education, right? So then Richard, please.
Well, I have to confess I'm very biased. So the area in which I work is bacteria. I love bacteria. I would hope to convince all of you that you should love bacteria too, because each of us depends heavily on the bacteria that live with us. If we kill all your bacteria, you die. You cannot live without them. And they do many, many wonderful things for us, and we don't understand that as well as we should. And so for me, the future is understanding, A, how bacteria work, B, how they compete with one another when necessary, and in particular, how they manage to keep us alive. I'll give you one example. Bacteria don't like us to get cancer. Why? Because we're their home. They don't want us to die. They like us. They want to stop us from dying if they can. And I think going forward, there've got to be many ways in which we can understand how bacteria help us, how they love us, how they will take care of us, and in particular, how to treat them better so that as we get older and older, as we get more and more knowledgeable, we can use these bacteria so that if there are bad ones around, we use good ones to kill them, to get rid of them. Maybe they can help us keep much healthier than we are at the moment. So I'm a huge fan of bacteria. I love them. I think you should too. And for me, this is the future. I'm hoping before I die to learn how a bacterium works. That would give me tremendous pleasure. I would just love that. So thank you.
Thank you so much. Well, then, Svante, please.
Well, I would perhaps start by saying I think the question is almost impossible to answer. Where will we go in the next 10 or 20 years? I have no clue. Obviously, we've gotten a sense today for sort of the frontiers where one is in many areas, and one can anticipate how that will be pushed forward. But the truly new things that will come, I have no clue. And no one else probably has either here. How can we sort of catalyze that type of progress? I think one thing is perhaps to invest in people more than in proposals, that after all just is generally an incremental advance. Some of science funding, I think, should go to investing in people that show progress and give them free hands for also longer periods, for 5 years, 10 years, to actually develop risky projects that may or may not work. And one should accept failure also in those endeavors.
Okay. Thank you so much. So the understanding bacteria from Richard, and then from Svante, it was to invest people more than expected for now. At least, yes. Right. Okay. Great. Okay, so then Tim, please.
So I must disagree with my friend Rich, because the only encounter I had with bacteria, I was almost dead, and we got rid of all my bacteria, and I was very much brought back to life. So there are good and bad sides of bacteria. One is often asked as a Nobel, what's the next big thing? And it always seems to me that's a very silly question, because as Svante said, you just don't know. And you can't imagine, because, you know, there's so much we don't know. And the worst stuff that we don't know is the stuff we don't know even exists, right? I mean, there's all kinds of things. And even physicists, you know, who we heard earlier from Kajita, I mean, you know, they don't understand gravity, for example, let alone dark matter and dark energy. I mean, there are huge, and those are the known unknowns. What about the unknown unknowns that we don't know about? So the answer, of course, as Svante also said, is to invest in people who are curious and who go out there and explore things. And that means finding smart people and just letting them loose, and insisting that they don't listen to people like us, dinosaurs.
Thank you so much. So unknown is so important, and to invest in people. So but in the previous session, so for example, as we listen to these enzymes and RNAs and all these things, which is also quite like a futuristic story that we could see. And also with the rapid emergence of all these AI technology, or new technologies, and that is not only for generative AI, but also for the data-driven approach, machine learning, and so on. So that I just would like to narrow down the topic that, so having these cutting-edge technologies, so these technologies would, what would be the impact of these technologies over biology, and also at the same time, can biology would make some impact over these new technologies, or especially in the field of, for example, computation, recently rapidly growing. And what would be the opportunities and what would be the risks? So anyone, yes, yeah, I can.
Have to say something.
Yeah, exactly.
Well, I probably don't have enough of a vision, but to my sense of AI and where it is and where it will go is a tremendously useful tool to handle massive amounts of data, and it will probably expand to other areas that we don't anticipate, make connections in this data that we cannot see as humans, and we sort of just have gotten a sense of that yet in predicting protein foldings, etc., etc. But on the same time, I think that are truly new things, the things that Tim mentioned, doing the things that are considered impossible, I doubt that the AIs will do. I think we need humans to take that really bold step. So I don't think AI will replace the next generation of PIs.
Yeah, but we heard about some challenge from Dr. Kitano about this, Nobel Prize-winning AI, right? Trying to make such kind of AI, but
Yeah,
it's a sort of a challenge, so grand challenge.
I'm very skeptical about AI. AI is terrific about telling you what train next to take to Kyoto, right? It should be good at that. Or even maybe finding out a nice restaurant. And it's very good at pattern recognition and altering people's faces on bodies and stuff. Surprising things that it's really, really good at. But in terms of, it seems to me, because it's based on what's already known, it's embedded with every prejudice as well as every accurate fact. So to that extent, it seems to me, but correct me if I'm wrong, must be dangerous actually, because it has no way of telling. How does it know what's the truth and what's not true? We know already that it can lie and cheat and steal. It's called hallucination. I dare say that will improve with time, but I don't understand how it knows. It's not logical. It's not. There's something uneasy that makes me uneasy about it.
Yeah, it's not so easy to make it sure that this is really the truth or not.
So, what sounds sort of funny to me is this sort of thing like we're suddenly going back to Aristotelian science. If you can think about it, you get an answer, you're done. And we all work by doing experiments. So the idea about AI is it would seem to me that it has the potential of being a terrific hypothesis generator, something that you could then test. And you look at all of the AlphaFold protein predictions are predictions. They're not answers. They're predictions that people then say, well, on the basis of this, then the following should happen, and we can modify it. I think that's a potential that's very good, but it really is, and there's been many articles about this, is sort of a human-machine interface where it's really both things. I'm going to say a ridiculous story. When I had to go in for a checkup, a medical procedure, the doctor said to me, you know, this time we're going to do it, we have an AI-generated thing. And I basically got up and cheered, because who doesn't want a second opinion? He wasn't saying, we're going to just, you know, put you in the machine, whatever that answer comes out. It's, we're going to do this, and if it happens to notice something I don't notice, I'm going to look at it and make a judgment on it. So it's like getting additional information. So I don't see it as a necessary evil, but I think it's problematic if we believe that it's going to give us the answer, that we don't have to do anything subsequent. I think there's a real need for experimentation and confirmation of what's happening.
So maybe I could say a few things here, since I'm a bioinformatician and I sit with a computer in front of me all day. I used to write programs. I now have a couple of people who write them for me. The thing about AI is that potentially it can be very valuable. But AI is only as good as the data set upon which it is trained. If you train it on rubbish, then you will get rubbish back. Chat GPT, which I always call cheat GPT, is a great example of this. It hallucinates. If you ask it certain things, ask it to write a paper, it will make up references. And so the thing we need to do is to say, what is that really good, reliable data set that we know is correct? And I can tell you from a scientific point of view, it's not the scientific literature. We know it's not the scientific literature because there's a lot of fraud in the literature. And so we need to go through the scientific literature as scientists, pick out the rubbish, throw it away, make sure that we have a really good data set, that we know maybe that everything has been experimentally verified in this data set, and then begin to let AI use it. But we must also make sure that AI tells us how it gets to its decision. If you look at current AI programs, they don't tell you how they reach the decision. They somehow want you, or the people who write them, don't want you to know how the AI works and gets to the decision. But we're scientists. We write a paper, we have a methods section which tells us how we get to the final answer. AI needs to do the same thing. So I'm very positive about AI, but I want to see it done properly, and I'm afraid it's not being done properly at the moment.
Can I add one thing more? This is an experiment I actually have done. I was sort of appalled by the fact that virtually every newscast I ever heard referring to AI brought up teachers being worried about their students cheating. That seemed to be the most dangerous part of AI. And so I asked AI to write an essay on my life. And since my name is unique, it had everything wrong. It gave me a sister named Karen. I don't have a sister. It had all sorts of things. Everything was incorrect. And this is exactly what I wanted. And I'm now using it in my advanced genetics course. I am feeding every one of the articles into 3 different chatbots, and we're getting their summaries with all the hallucinations. And what we're doing with them is what I think teachers should do in general with this. I'm giving those summaries to the students and telling them to fact check them, because it is the idea of being able to really determine what the basis of things are. So it's not just, it's again gets back to this believing, but if you can just take this stuff and give it to people and say, okay, now what was true and what's not true in this? And where should it go further than this? And what do you think the next experiment is going to be? All of those questions that can't be answered in this in my belief, is going to produce really terrific students to work on various important science problems.
Well, okay, thank you so much. And so there's any comments over this, the other way around, so that AI or those kind of tools impact over biology, but biology could make some impact over the Yes.
So if I am allowed to go back to the example that I brought in the earlier discussion, that every peptide bond is made the same way with the same geometry, this already kills a lot of possibilities that peptide bonds can be all types. And the ribosome knows to either to moderate it or to kick it out. And I think if one looks at this problem from this point of view, maybe we can become much more clever.
Okay, thank you so much. Thank you so much. So, any other comments over this, the impact of biology over these new technologies or new computing methodology or whatever? No? If that's the case, maybe we could also ask the comments from the audience. Is there anyone who's, the questions to the panelists or the comments over this
Paul,
question and so on?
Paul, I think you should say something about
okay.
AlphaFold.
Yes. Yes. No, Paul, yes.
I think I briefly commented on AI. I'm not sure I say anything about AlphaFold, which is a very, very useful tool, but needs, as we've heard, experimental verification. And hopefully over the years it will get better and better at its predictions. I mean, what I think we're hearing particularly today is we get very irritated when so many people just use the words AI and think it solves the world. So we are very irritated. We do probably need to control that irritation a bit, just in case we throw babies out with the bathwater. So, but I get irritated as well. Any board meeting I go and I get these ignorant business people telling me this is the answer to everything. It just makes me cross. So what do I think about AI and science? I think firstly, I mean, it's actually a very useful laboratory tool for doing things. And let's not get rid of that. I mean, it is a useful tool. Secondly, the literature, it hallucinates like crazy, of course, but it can provide something very quickly that might be helpful as long as you are very critical of it. The third thing I want to say, though, is we should be looking over the horizon beyond AI to something else, something which is sometimes called, artificial general intelligence, where maybe it can be creative, because it isn't being creative. And I tried to touch upon that when I said we have to understand the complexity of living things, because we will need people who can think about information and the management of information, and AI could contribute to that. But it isn't able to, in my view, at this present time. Now, the really thoughtful people in AI, and I'm thinking of my friend Demis Hassabis, for example, and John Jumpers, have fully realized this. We constantly talk about it, and we are constantly not doing anything because we don't quite know what to do. Eventually, maybe we could. So where I come on it is we can use it, we are using it, we shouldn't sneer at everything. And it is useful. It is over-egged, and we're going to see a collapse. Look how much is being invested. I mean, it will collapse, and we just have to be aware of that. But we do need to think about how we can use it. And somebody on the channel, I think, put their finger on it. It isn't revealed to us how AI is making its steps of decision-making in its process. Now, I think the most profitable approach, for me personally, is to combine the human mind more on board with actually the processes which the AI processes are going through. In other words, we have a combined human brain creativity and the ability of AI to do things. And I think that, rather than trying to simply invent something that's totally independent of creativity in the brain, of thinking how you can embed it into actually the processes, is where I think we should go. I believe people are thinking about this. And I think that's where I think that there could be profit to solve the very complex problems of biology.
Thank you so much. So it's a combined use with the human brain. So yes, please. Who? Well?
Thank you very much. I would like to ask a question, two questions, not directly. One is directed, related to the AI thing. Do you think, like as scientists, the fear we have regarding AI, is it similar to how the public also is scared of vaccines, let's say about RNA vaccines, because we don't know what can happen, so we do have this fear. But from the point of view of a scientist to the public, do you think also there is a possibility of considering AI like with an open-minded approach and use it for science, not against science? And I also want to ask a second question. How did the Nobel Prize change your lives and careers? Yes. Thank you very much.
Okay, thank you so much. So the first one is very much related to the also the presentation in the previous session by the Thomas. So can you have some answers to these questions? Of course, the second one will be so you could answer to the questions.
So let me make one comment about the first question. Obviously, these ideas, like conspiracy theories and things that vaccines are bad and so on, they're the result of social media behaving very badly. And just how one fixes that is not clear to me. You would like to think that we could put in place rules that would say what was and wasn't acceptable on social media. Maybe we could put in place programs that will monitor what is being said and then have rules which will say, well, if you're just telling lies on social media, you're not allowed to be a part of that. But then that affects free speech and what we think about free speech and so on. And so personally, I do not participate in social media, and I don't think it is very good, and I don't think it's certainly not very good for democracy. But just how you control it, I don't know, and the politicians have not managed to come up with a way to control it anyway. And on the vaccine question specifically, I think we've done a terrible job of letting people speak against vaccines in public places when they should know better. RFK Jr. is the person that comes to mind in the US, but now Trump is following him too. And this is the man who, made sure that the COVID virus got through and got to many, many people. And so, politicians just lie all the time. It's crazy. It's really bad. But the vaccines are the best thing, the best medicine we've ever come across. And to hear people saying, oh, I won't take it, I'm scared to take it, and then to tell you that how dangerous it is, and Bill Gates is busy putting microchips in, I mean, this nonsense. We have to find a way to stop it. How we do that, I don't know.
Okay, so, yes. Go ahead. Yeah. No, please.
So I think there's another aspect to this. I mean, when I look at the sort of history of molecular biology, when there was questions initially about if there were dangers with recombinant DNA technology, it was the scientists that got together to decide that they wanted to have a moratorium to think about what these things were and to develop ideas. When CRISPR-Cas9 came in, it was Jennifer Doudna and others that got together people to say, we have to think about the ethical considerations about these things. It's not, we should be afraid of this and never do it. It's, what are the limits that we need to put? So if we go back to the AI example, I think it would be a disaster if countries decided that the 9 nuclear countries in the world, if they decided to let AI control their nuclear armaments. That would be a disaster for doing it. But that's not an argument against AI. That's an argument for thinking about what are the right guidelines and how should guidelines be implemented. And I think that's the important aspect of this, not to rail against a technology because of what one person imagines might happen. It's deciding what limits we want as human beings on these areas.
Thank you so much. So to wrap up this session and also for the whole meeting, I would like to ask the wrap-up comment from you, maybe 1 minute each or so. So start from Ada, and especially for the young generations. So to, yeah.
Just to finish up, my own impression is that young people, new scientists, as well as established scientists, could learn a lot and will be able, hopefully, to use at least part of what they studied, maybe most of what they studied, in their future experimental plan. And I wish all of you, those that agree and those that don't agree, best of luck.
Thank you. Thank you so much. Thank you.
So I think I would imagine that for most of us, as we get on in years, it's really annoying because we want to know what's going to happen next. We want to be excited about it. So I think that my only question is, go off and do it. Have a great time and just wow us with what these discoveries are going to be that we don't even imagine yet. So I'm looking forward to continuing to learn from the people that are really going to make the discoveries.
Well, of course, it's very hard to argue with that. I certainly wouldn't try to argue with that. I think there are several things that I always tell students. One is, you will be lucky during your lives. Make the most of it when luck comes your way. Don't feel guilty because you had it and your friend didn't. Also, embrace failure. Failure is a good thing. You know, I won the Nobel Prize because we were doing one experiment and it didn't work. And we spent almost a year trying to figure out why it didn't work, and it was because nature was trying to tell us something. And when you go looking, doing hypotheses, testing hypotheses, doing experiments, sometimes things don't work because you drop the tube on the floor, but sometimes nature is trying to tell you something. Be optimistic, okay? There is so much that we don't know about nature that I think anyone in the biological field has to feel grateful that here is where you're really going to learn and make discoveries. The opportunities are immense. And for me, I love getting up on a Monday morning and going to work. And on a Friday, I wonder how I'm going to manage to get some work done over the weekend if my wife will give me a little time so that I can do it. I think I love what I do. I don't think I've worked a day in my life, to be honest. So science is a very good thing.
Well, yes, I agree with everything that has been said. I would say if there would be some advice, so yes, do what you enjoy doing, follow sort of your passion, because at least you have a good time while you're doing it then, whatever then happens. But keep a cool head. Take advice and think about when is the time to change direction, because there's also a time when you need to think about another project than the one you're working on.
Yeah. So probably the best advice I ever received as an undergraduate student, actually, the professor of biochemistry said, "Don't believe a word you read." And, well, you know, and so we were very skeptical, actually. It meant that one didn't read the materials and methods quite as carefully as perhaps one should have. On the other hand, it gave your research enormous robustness, because you sort of had to find out for yourself how to do anything. And, you know, not be afraid to try some new method. I mean, often it didn't work. Sometimes because the thing you bought from the chemical company wasn't what it said on the label. That's happened to me more than once. And if things don't work, then what do? Well, you first repeat it and it doesn't work again. So why isn't it working? Troubleshooting is what you spend most of your time doing, in my experience, and it can get rather depressing. And sometimes that's because nature is trying to tell you that you're barking up the wrong tree, and sometimes it's telling you you're an idiot because you didn't read and take a proper advice. And it's a very, very difficult business, I think, being a scientist. But in the end, you know, if you make some progress, it's tremendous fun. There's nothing so much fun as finding out something that you didn't know. And in order to do that, you just have to have some confidence in your own belief and just keep going. Just keep going. And then, you know, if it doesn't work that way, try and see if there isn't a sort of little sneaky way around the back, because maybe, you know, there is, and that's the way forward. So, again, good luck. Keep going, and we expect great surprises and great things of you.
Thank you so much for all of your very much inspiring points. And with that, I would like to close this session. So please join me to thank all the panelists. Thank you so much.